purpose of this video is to review everything we've covered in Chapter 5. We're having our Chapter 5 test, and I thought it'd be helpful to go have a review video that has a bit of everything in it. We learned about exponents, scientific notation, and square roots in Chapter 5. We learned how to write exponents, using exponents. If you had x times x times x times x, you got x to the whatever power. We learned how to multiply and divide with the exponents. We learned about negative exponents, power to a power, and that covered exponents. We also did scientific notation, converting to scientific notation or converting from scientific notation to standard notation. Multiplying and dividing with scientific notation. We also learned about adding and subtracting with scientific notation. And although it's not going to be on the Chapter 5 test, I have put adding and subtracting examples at the end of this video. Square roots, we learned how to calculate them, plugging them into our calculator, hitting the square root button. Estimate, we learned how to estimate square roots using those perfect squares. Multiplying, when you multiply two square roots together, it's the same as multiplying the radicands, the numbers underneath, and then getting the square root of the result. Fractions, the square root of a fraction is the same as the square root of the top or the square root of the bottom. And we learned problems involving squares when you got something like the area of a square and you were asked to find the perimeter. All of these are question types that could pop up on the Chapter 5 test. So, if you want to pause as we go along, every time I come on one of these screens, I will step out of the way so you can pause it. I'll come back and I will automatically go through all these problems. This one here, we have x times x times x, that's 4 x's, so that's x to the 4th power. 1, 2, 3 y's, so that's y to the 3rd power. Only the 1 z, so that's z. You could put z to the 1, but it's not necessary to have that 1 there. It is still the same either way. Here we have negative 3. We have 1, 2, 3, 4, 5, 6, 7 negative 3's. Now notice how I'm putting them inside of the parentheses, because when I put that power of 7 on there, I have to note that it is including that negative in the exponent. Now the 4, I could write it inside of parentheses and put the square on the outside, or I could write it without the parentheses. It would still be the same. But this negative 3, you have to have those parentheses around it. Question number 3, we have the same fraction being multiplied by itself 3 times. So that's 4 over 5 within parentheses to the 3rd power. Multiply, when you're multiplying the like bases, you add the exponents. So this becomes 17 to the 5 plus 3, which is going to give you 17 to the 8th power. Here we have combination. We have two monomials being multiplied. What you're going to do is you're going to multiply the 3 and the 4, the two front numbers, coefficients, and then you're also going to multiply the like bases. When you multiply the 3 and the 4, you get 12. When you multiply the like bases, you're going to add the exponents, and you're going to get x to the 7th power. So that's your answer on that one. Here, we're going to do the same thing. Front times front is going to give you negative 30. X squared times x cubed. You add the exponents, you're going to get x to the 5th power. Y times y to the 5th. This is saying y to the 1, so I'm going to add 1 to 5, and I get y to the 6th power. There's no z here, but there is a z here, and it's all being multiplied, so it just gets tacked on to the end as being a z on the end there. So the final answer there is negative 30 times x to the 5th, y to the 6th, z. Next, we're going to talk about dividing with exponents. All right, to do these, when you're dividing, instead of adding the exponents, you're going to subtract the exponents. So this becomes x to the 31 minus 10, which gives you x to the 21st power. That's simplified. Here, to simplify this, you need to look at it as if it's two separate fractions. Negative 16 divided by 2 is going to give me negative 8. y to the 5th over y is going to be y to the 5 minus 1, which is going to end up giving me negative 8 y to the 4th power there. Here, this becomes 8 to the 23 minus 5. Don't be fooled. A lot of times when students see the 8 over 8, they think in terms of like the 16 over 2 and think that you have to divide it and it becomes 1. But be careful. Here, the numbers are the base of that power, and when they're the base, you carry them through. You do not do that division like that. By taking care of the exponents here, you are doing that dividing. You are doing that canceling out, and you end up with, in this case, 8 to the 18th power. It does not become a 1 here. It stays an 8. When you're given negative exponents and you're asked to simplify, if you've got a number in here, to simplify it, you would start off by putting it under 1 with a positive exponent. Because moving a negative exponent to the bottom of a fraction makes the exponent positive. 1 over 7 squared is 1 over 49, and that would be your simplified answer there. Yes, when you've got a number like this with an exponent that small, you would be expected to work it out to a final number there. Doesn't say anything about express your answer using exponents. 2 to the negative 5. Again, this becomes positive on the bottom of a fraction. So we have 2 to the positive 5. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So we have 1 over 32, and that's your answer for that one. Here, this is going to end up being 1 over 3 to the positive 4. 3 times 3 is 9, times 3 is 27, times 3 again, you get 1 over 81 for your answer there. Now here you're asked to express using positive exponents. To do this one with positive exponents, it's simply a matter of putting it on the bottom of a fraction. The same thing's going to be true here, but what you have here is 4 times 1 over y to the positive 3, which means the 4 is actually going to stay on top. And you end up with 4 over y to the 3rd power. Here, the negative exponent's on the bottom. To make it positive, you would move it to the top. So this becomes z to the positive 4th power. Exponents, power to a power. When you have a power to a power, this is an exponent to an exponent, you need to multiply those powers. So this becomes b to the 2 times 8, which gives you b to the 16th. Here we're going to multiply negative 3 times negative 4. You're going to get x to the positive 12. Here we've got an exponent to an exponent to an exponent. This just becomes c to the 2 times 3 times 5, multiplying all 3 of those. 2 times 3 is 6, times 5 gives you c to the 30th power. Here, we got to remember when you've got a monomial being raised to a power, both the 7 gets squared and the x to the 18th is going to get squared, which means you're going to multiply those exponents. 7 squared gives you 49. X to the 18 times 2 is going to give you x to the 36th power. Here, 2 to the 3rd. X to the 13 times 3 is going to be x to the 39th. Y to the 5 times 3 is going to be y to the 15th. Z is understood to actually have a power of 1 there. So when you do 1 times 3, you're going to get z to the 3rd power. This does need to be simplified here, the 2 to the 3rd, which is going to give you 2, 4, 8 You get 8 times x to the 39, y to the 15, z to the third power. And moving on to scientific notation. Converting scientific notation, when you're asked to write in standard form, they're talking about writing it, well, they're talking about writing it in normal 10 power forms, meaning just the regular number writing. This is 3.5 times 10 to the third. That's making it larger. A positive exponent is making it larger. 3 place values larger means we're going to 1, 2, 3. We're going to fill these in with zeros. We get 3,500 for the answer there. Here we're making it 5 place values smaller. 1, 2, 3, 4, 5. So it's 1, 2, 3, 4 zeros being added in there. We get 0, 1, 2, 3, 4 times, so 4 zeros, 4, 1, 7. And that's your 2 answers there. Remember, I don't want to see in a short response, I don't want to see your answer with the bumps on it there, the double decimal points. Rewrite it without your work so I can see it clearly. Write in scientific notation. To convert from regular standard form to scientific notation, when we look at the number, we go from left to right, and the first number we see that's not a 0, we're going to put a decimal point after it. So our front number is going to be 5.387. And we're going to have times 10 to the something. Well, to get the point to this point, I had to move over 1, 2, 3, 4 place values. So I'm going to have a 10 to the 4. This number started off as less than 1 in value, which means I'm going to have a negative exponent on it. That's my answer on this one. Over here, the first number from left to right that I see that is not a 0 is the 1, so I put the decimal point after that. This becomes 1.039 times 10 to the something. Well, the decimal point starts off over here. To get from here to here, I have to go over 1, 2, 3, 4, 5, 6 place values. So I get 1.039 times 10 to the 6th. And it is a positive 6 because this is a number that is bigger than 1 to start with. Scientific notation, multiplying and dividing. When you're asked to multiply or divide, you're going to work with the front numbers doing the operation you're asked to do. And when you're multiplying, you're going to add the bases, just like you did with multiplying like bases and exponents. And when you're dividing, you're going to subtract them. So number 25 here, we're going to do 3.8 times 4.2. This times this, and we get 15.96. Then we're going to add the exponents. 5 plus 8 is going to give me 13. Now my problem here is that this answer is not in scientific notation because this number is now greater than 10. So I need to move it over 1 place value, making this 1 place value smaller, which means I need to add 1 to here, the exponents, making it 1 power of 10 larger, which gives me 1.596 times 10 to the 14th power for my final answer there. Here I'm going to do 1.2, the front number, times the front number, times 3.5. Gives me 4.2. And I'm going to have times 10, adding the exponents. This is a negative 3, that's a positive 4, adding them together I get a 1. So I get a 4.2 times 10 to the 1. Here, I'm dividing, so I'm going to take those front numbers, 3.6 divided by 1.8, and I get an answer of 2. 10 to the 8th, 10 to the 5th, I'm going to subtract 8 minus the 5. 8 minus the 5 gives me 3. And there's my answer on that one. Here I'm going to do 5.2 divided by 1.3. And I get an answer of 4. And I'm going to have a times 10. I'm going to subtract the exponents. This is going to be 3 minus 9, which gives me a negative 6. So I end up with 4 times 10 to the negative 6 for my answer there. And yes, it's okay for the exponents to end up being negative. Now it comes to square roots. If you're asked to calculate, it really just is as simple as typing the number 36, hitting the square root. Ignore this sign when you're working with the calculator. When I do this, I get an answer of 6. Then what I do is I carry these signs over to my answer, plus or minus 6. So I actually have 2 answers, both the positive 6 and the negative 6, and I show that with that plus and minus. Here, I do the 196, do the square root, and it's going to give me 14. Carry the negative sign over, I get negative 14 for my answer. Over here, I do the square root of 225, and I'm going to get 15. No sign on the answer. It just stays as 15. Here, I'm going to try doing the square root of a negative, and the answer is going to be no real solution. And yes, I would expect you to write the words out. Now when it comes to estimating, you need to work with these perfect squares. I highly recommend you work on memorizing those, as you were supposed to memorize them with earlier in the semester there. If not, we're going to start counting up. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5, 6, 7, 8, 9, 10. That'll help you work out the perfect squares. Looking at these, I happen to know that 220 is between the perfect square of 196 and 225, somewhere in between there. Is it closer to 225 or 196? Well, it's closer to 225. And 225, the square root of that is 15, as we found out up there. This would be 14. So it's in between those two, closer to the 15 square root, so that's what you get. This one, 39. 36 is 6 squared. 7 squared, the next one up, is 49. Which one is this closer to? It's closer to 36 than it is to 39, so this rounds or estimates to 6. This is between 81 and 100, somewhere in between those two. It's a lot closer to 100 than it is to 81. Square root of 100 is 10. So there's our estimations. Square roots multiplying fractions. When you've got a fraction inside of a square root, that's the same as saying the square root of the top number over the square root of the bottom number. And in this case, it does make it simpler. The square root of 25 is going to be 5. The square root of 36 is going to be 6. So you end up getting 5 6 for your answer. Meanwhile, if you try to do 25 divided by 36, you might end up with this messy decimal, and you do the square root, and it ends up another decimal because it's rounding errors. Stick with this. Here, same deal, square root of 49 over the square root of 100. This is equal to that. Square root of 49 is 7, square root of 100 is 10. Our answer is 7/10. Here, we got the square root of 3 times the square root of 12. Square root of 3 is going to be a big decimal. Square root of 12 is going to give me this weird decimal. But when I multiply them together, doing 3 times 12, I get the square root of 36, which is 6. Here, I see I'm doing square root of 8 times square root of 8, which is going to give me the square root of 8 times 8, which is equal to square root of 64, which is equal to, dun-da-da, 8. Anytime you multiply a square root by itself, you're going to get the radicand. The radicand being the number underneath the radical symbol. All right, you may be asked to solve. To solve using square roots, you are going to do the square root. And whenever you do the square root to solve, it's got to be the plus or minus both the positive and negative solution of that. So the square root of 64 ends up being 8. So you get x is equal to positive or negative 8 in this case. In this case, when you do the square roots, plus or minus, you're going to get y is equal to plus or minus 10. And that's your answer here. You could be asked to solve a question like this, where you're given a square, or they want to plant some seeds in a square pattern or something like that. Lots of different ways of asking this question, which basically comes down to an area being given, and you're being asked for the perimeter. Remember, area is equal to side squared, so the length of a side squared, in this case, is going to be 100. Square root to solve from there to find out what the side is. Technically, it should be plus or minus, but we're talking about a length. You're not going to have a negative length. So we're worrying about just the positive version of 10. Now, that's the length of the side, but they didn't ask for that. They asked for the perimeter. And the perimeter is equal to 4 times the side, which is going to give me 4 times 10, which is 40. And don't forget, whatever units they give you, if they give you inches squared, it's going to be inches. If they give you centimeters squared, it's going to be centimeters. Because the area is measured in square units, the perimeter is not. It's measured in just regular old straightforward units. Scientific notation, adding and subtracting. Now, again, I'm not going to have this on my Chapter 5 test, but we did go over it. So I want to include some practice with it here too. Here, the temptation is to work with the multiplying and dividing rules, which says just go ahead and work with those front numbers. But when you're adding and subtracting scientific notation, you have to have a common exponent on the tens first. So I make this into a 10 to the 5th power. By doing that, I raise this up by 1 power, which means I need to make this 1 power smaller by moving it over 1 to the left there. And that gives me 0.4 times 10 to the 5th. Now that I have like exponents, now I can work with these modified front numbers, and I can actually do the adding. 3 plus 0.4 is going to give me 3.4. 10 to the 5th, 10 to the 5th, that gets carried over, it gets carried along. Remember, it's a lot like the rules for adding and subtracting fractions. With adding and subtracting fractions, you have to have a common denominator. With scientific notation, you have to have the common exponent. All right, here I've got 10 to the 18th, 10 to the 17th, and I'm subtracting. Same thing, you got to get the common exponent there. So I'm going to change this one to times 10 to the 18th. I like to make the smaller ones into the bigger ones. It generally creates less work later. Since I made this one larger, I need to make this one place value smaller, which makes this 0.23, going over 1 this way. This stays the same. Now I can do 3.27 minus 0.23, and that's going to give me 3.04. And I carry along the times 10 to the 18th power. And that's going to be my answer there. Here, you'll notice that this one, this time, it's the, well, it's going to be this one. This one is not a jump of 1, it's a jump of 2. To get from 90 to 92, I've got to make this times 10 to the 92. Which means I made this 2 place values larger, which means I need to make this 2 place values 1, 2 smaller, which makes it 0.038 times 10 to the 92. And now when I add these two together, I'm going to get 5.378 times 10 to the 92. And that's my final answer on that problem. That's Chapter 5 in a nutshell. See you in class.